So first, let's go through definitions. A linear pair is two adjacent angles, okay? And adjacent means that they share a vertex and a side, but they do not overlap, okay? So if I had this, for example, there's adjacent angles here. This one and this one, because they share this side and this vertex. But if you said, wait a minute, what if they share this side and this vertex, and one angle is this, and the other one is this? Are those adjacent angles? And the answer is no, because they overlap. Okay? So a linear pair are adjacent angles whose non-common sides, the sides that they don't share, form a straight line. Okay? And what that means is that a linear pair are always supplementary. The two angles add up to 180 degrees. And there are lots of them here. Just sort of to go through it, 1 and 2, 2 and 3, 3 and 4, 4 and 1, all of these are linear pairs. These two, these two, these two, these two, and the same thing down here, 5 and 6, 6 and 7, 7 and 8, and then 8 and 5. It's important to notice that I've asked for one and only one pair. So giving me the whole list would be the wrong thing to do. Vertical angles are two angles that share a vertex and their sides form straight lines. Right? This is a straight line, this is a straight line, here's the vertex. So this side and this side, this side and this side, these are vertical angles. And these are also vertical angles. And the deal with vertical angles is they are always congruent. Here we have 1 and 3, 2 and 4, 5 and 7, and 6 and 8. Corresponding angles. The deal with corresponding angles, first of all, is that they are not at the same intersection. None of these are corresponding angles to each other. Neither are these. Corresponding angles are created by a line that crosses two other lines. And this line is called a transversal. So, what are corresponding angles? They are the angles that are in the same relative position in the two intersections. So if you're looking here, the 3 is on the upper right side. Down here, the 5 is on the upper right side. So 3 and 5 are corresponding angles. 6 and 4, upper left side. 1 and 7, lower left side. 2 and 8, lower right side. Those are the ones that correspond. Now, in any situation like this, this is the transversal. This and this are the two lines that the transversal crosses. In a masterstroke of creative naming, we call this the interior, because it's in between the two lines. And what's left out here and out here are the exterior. So some angles are on the interior, some are on the exterior. So that sort of tells you where they are this way. Where they are this way, they can either be on the same side of the transversal, or they could be on alternate sides of the transversal. One here, one here. Alternate interior angles and same side interior angles are both, like corresponding angles, something where you have to have angles at two different intersections. Right? 1 and 2 are not alternate interior angles, even though they're inside and they're on opposite sides of the transversal. They are not alternate interior angles. In order to be alternate interior angles, they have to be at different intersections. So 1 and 5, those are alternate interior angles. 2 and 6, those are alternate interior angles. And that's it. Same side interior angles, 1 and 6, 2 and 5. Now, here is the reason that you learn all of this. We've already said that vertical angles are congruent. So this angle is congruent to this angle. This one is congruent to this one. This one is congruent to this one. And this one is congruent to this one. Okay? If, okay, there is a situation here. There are two situations. One is you can come in the room and know something about the lines. The other is you could come into the room and know something about the angles. Okay. If you know that the lines are parallel, okay, if you know that the lines are parallel, then what you know is that the corresponding angles are congruent. Now, check this out. This is congruent to this now, right? This is also congruent to this, and that means these two are congruent. Well, so then alternate interior angles are also congruent. And not only that, but we know this is a linear pair and this is a linear pair, so these are supplementary. And these two are congruent, so these have to be supplementary, right? This plus this is 180, this is the same as this, so this plus this has to be 180. Same side, interior angles are supplementary. These are not three different things. These are really three parts of a situation that occurs when you find out that lines are parallel. Because if you find out any one of these, the other two are going to be true. If you walk in the room and you don't know if the lines are parallel, they're not marked, but you see the angles and you can see that you have this situation, because you notice one of these three things, which means the other two are also true. Okay. That means the lines are parallel. So if the lines are parallel, you know the situation exists. If you walk in and find out the situation exists, you know the lines are parallel. These are two different things that can happen, so they have two different names. This is called the corresponding angles theorem, or the alternate angles theorem, or the same side interior angles theorem. This one over here, because it's the opposite of this, is called the corresponding angles theorem converse, or the alternate interior angles theorem converse, or the same side interior angles theorem converse. So this is the theorem converse. That way you don't have to write a whole lot. You have to write which one of these three things you noticed. If you already know that the lines are parallel, then, and that tells you something about the angles, that's the theorem. If you find something about the angles and that's what tells you that the lines are parallel, that's the theorem converse.